Shana, are you there?
Okay, sorry, I'm ready.
Shana, so we do have to discuss the question number 24 and 24, right? 24 and 25, right?
Yeah.
Okay. Could you please read out the question number 24 for me?
Okay. Quadrilateral ABCD has angle BCD equals angle DAB equals 90. The perimeter of ABCD is 224 and the area is 2,205. One side of ABCD has length 7. The remaining 3 sides have integer lengths. The sum of the squares of the side lengths of ABCD is S. What is the integer formed by the rightmost 2 digits of S?
The rightmost 2 digits of S. Okay. All right, just let's go through the solution. Excuse me. So, in the question, it is mentioned that the 3 sides of the quadrilateral are unknown. So, you can
Yeah.
assume some variables for that. So, you can draw a quadrilateral with 4 sides. So, you have A, B, C, D. You do have 4 vertex.
Yeah.
Then AB is going to be X, BC is going to be Y, DC is going to be Z. You can assume any variable. It's completely your choice. So the last one is already given in the question. The DA is equal to 7 is given in the question.
Yeah.
You've been told that the X, Y, and Z are integers. And we know what is perimeter. The perimeter means?
The total sum of the sides.
Exactly. Yeah, the total sum of the sides. So you just have to add all the 4 sides and you have to equate it to the perimeter. So it's X plus Y plus Z plus 7 is equal to 224, right? So when you subtract this 7 from the 224, you'll be able to find the value for X plus Y plus Z, which is 217, right? So here you are dividing the quadrilateral into 2 parts by drawing a diagonal line. You'll be able to see a line DB.
Yeah.
That is a diagonal line. So now you can create two triangle. The triangle DAB, which is of course a right angled triangle. And you do have another triangle, which is DCB or BCD, whatever. Is it clear? So you are able to create 2 triangles. Rather than calculating the entire area of a quadrilateral, you can find out the area of 2 triangles and you can find their sum, which is equal to quadrilateral area. Is it clear?
Yeah.
Yeah. So you know the formula for the right angle triangle, which is half into base into height. So the base is going to be AB and height is going to be DA. So let me do it here. It's half times base times height. The value of base is going to be AB. The value of height is going to be, I'm just focusing on this triangle now. The height is going to be DA. Half, the value of AB is X. The value of DA is going to be 7. So the answer is 7x over 2. So now let's focus on the other side of the triangle, which is DCB. So again, it's going to be like half times base times h. The base is going to be DC and the height is going to be DC. And the DC value is unknown, so you can assume that as Z. The value of BC is also unknown here, which is Y here. So that's going to be YZ over 2. So you do have YZ over 2 and 7x over 2. So you can consider this as the area of the quadrilateral. So 7x by 2 plus YZ over 2, which is nothing but 7x plus YZ, right? Half plus half will give you 1. So the, wait a minute, what did I do? For the denominator, no. It would be like 7x plus YZ over 2.
Yeah. Because it's the area of a
We do
triangle.
have some coefficients. We won't be able to add it directly. That's the problem. You can only take the 1 by 2 common outside. You won't be able to make 1 by 2 and 1 by
Yeah,
2.
but there's no common.
Yes. No. I was saying that 7x also has the denominator as 2. YZ also has the denominator as 2.
Yeah.
One thing you can do is you can write it as like 1 by 2 times of 7x plus YZ. This is
Yeah.
possible. This is possible. You won't be able to add 1 by 2 and 1 by 2 as 1. That is not possible. All right.
Yeah.
So this is there. So this is the area of the quadrilateral now. When you add the two areas of the right angle triangle, and in the question it is mentioned that the area of the quadrilateral is 2205. So let's equate that. So when you equate this 2205, you can multiply both the side by 2 for cancelling out the 2. You will be having like 4410 is equal to 7x plus YZ. Is it clear? So you'll be able to obtain. Yes, Shana?
Yeah.
All right.
Because you doubled it with the 2.
Yes. Just for cancelling the denominator 2, I just doubled both the sides.
Yeah.
All right. So now we are going to determine x, y, z. That is our aim. So now I'm going to use Pythagorean theorem on the right angle triangle because we are very familiar with that. Hypotenuse the whole square is equal to sum of the squares of the adjacent side and the opposite side, isn't it? So you can apply that law. So according to that, dB square, this is going to be hypotenuse. Let me draw it here. If I assume this DBC, the lengthiest one, the side whichever lies opposite to the 90-degree angle is known as hypotenuse. This is going to be my hypotenuse, right? So this hypotenuse must be equal to the sum of the squares of the other two sides, which is CB square and DC square. So that would be like DBD whole square is equal to CB square plus DC square, right? DC or CD, whatever, order doesn't matter, right? So you're doing the same for this triangle as well. Again, it's going to be like DB square is equal to DA square and AB square, right? So you'll be able to create an equation like this. You'll be able to see DB square for both the triangles, which is common. So which is why they have just written this as a single equation. Okay. So from that, we can come to a conclusion. AB can be written as, I'll just do it here. DA square plus AB, supposed to be like this. AB square is equal to DB square. And what is DA? DA is 7. And what is AB? It's X. And DB is going to be DB only. Right? And what about this? BC square plus CD square. It's going to be Y square and Z square, right?
Yeah.
So it would be like 7 square can be written as 49 plus X square is equal to DB square. Let's assume this as equation 1. Again, the same DB square can be written as Y square plus Z square. So now let's equate equation 1 and 2. You will be having like 49 plus X square is equal to Y square plus Z square. Is it clear?
Yeah. But how are we supposed to simplify this?
This part?
Yeah.
Yeah, we can do that. It's easy only. I'll tell you how to. It's easy. This one we found it from the perimeter conclusion. You remember? We found the answer as x plus y plus z is equal to 217. Do you remember this from the perimeter part?
Yeah.
Yeah, you do. All right. So from this, you can write the value of x as 217 minus y minus z. We can do
Yeah.
that. And also from the area of the quadrilateral, 4410 can be written as 7 into x plus yz. I'm going
Yeah,
to
so then if you
substitute the x
substitute them, you
value
don't need
here.
x.
Yes. So when you substitute the value of x in terms of y and z, you would be able to omit one variable. We would be able to omit the x variable here. So we can deduce the 3 variable equation into 2 variable equation. Did you get that?
Yeah.
So now you just have to simplify this. You just have to multiply this by 7. And you just have to simplify this. And you just have to take the 1519 to the left side. It becomes like 2891, which would give you like yz minus 7y minus 7z. And from here, they're just taking y as common outside. It's going to be like y times z minus 7 into minus 7z. So, and here, they're going to simplify this further. For simplifying it, they are just adding and subtracting 49 here.
Oh, so that you can get,
Factorize this.
yeah.
So, we do have minus 7z already. So, this would be positive 7. And you just have to take this minus 9 to the other side. It becomes like 2891 plus 49 is equal to y times z minus 7 minus 7z plus 49. And this sum would be 2940 is equal to y times of z minus 7. And you can rewrite this as 49 is nothing but 7 times 7. So I can take 1 7 outside of it. That would give me z minus 7. Minus 7 into minus 7 would give you 49. Is it clear?
Yeah.
Okay. So now you do have z minus 7 and z minus 7 that can be taken as common outside. And you just have to combine these two, which is y minus 7. So that would be like 2940 is equal to y minus 7 and z minus 7. So from that, you just have to find the positive divisor pair for the 2940. It's going to be easy from here.
Oh, okay.
You look at them. They are in multiplication. So
Okay.
for obtaining the positive divisor pair, both either should be positive, either or negative, right? Because plus into plus would be plus, minus into minus would be plus. You're not supposed to have one positive and one negative and one positive. Either both should be positive or both negative. Do you understand? Then only their product would give you a positive divisor. So the value of y and z ranges from 0 to 7, 0 to 7. Is it clear?
Yeah.
For example, let me substitute the value as 5 maybe. I will have 5 minus 7 for y. Let me substitute the value of z as 4. It will give me like 4 minus 7. So this is going to be in minus 2 and this would give me minus 3. Negative into negative will turn into positive. It will give me like plus 6. So I'll be able to obtain the divisor as positive. Okay. In the beginning, when we found the perimeter, we were doing like x plus y plus z is equal to 214,
Yeah.
right? And we
Yeah.
were taking x is equal to 217 minus of y plus z. So you can write it
Yeah.
either way as well. You can write it like y plus z is equal to 217 minus x also. You can do that as well.
Oh, yeah.
By doing that, we can say this y plus z must be lesser than 217 because when you substitute some values for x, that would be
Yeah.
lesser than 217, isn't it?
Yeah.
You subtract.
Yeah, because x is a positive number.
Exactly. So, and also they're saying that sum. Okay, so they're saying that y minus 7 plus z minus 7 is less than 203. This I'm not sure. 1 minute, 203. How did they get that? Oh, I get it. So y plus z less than 217. So now they have just subtracted 7 values from here. And again, they have subtracted 7 values from here. So together they are subtracting 14 values, right? So if you're doing something on the left-hand side, you got to do the same on the right-hand side as well to maintain the balance, right? So 217 minus 14 will give you 203. Is it clear? So that is how you do have y minus 7 plus, I mean, it's supposed to be z here. Z minus 7 is lesser than 203. Do you understand this?
Yeah.
All right. And they're just writing 2940 in the form of a factor. So they're writing this is 20 times 147, and 20 can be written as 4 into 5. 4 can be written as 2 square. And they're factorizing 147 as well. You are getting 3 into 49. 49 can be written as 7 square. So here it's just factors, which is in the form of a positive integer. 2 square, 5 power 1, 3 power 1, 7 power 2. But do you think the power can vary?
Um,
For example, when I factorize 2940, here you'll be able to notice only 1 5 here. What if I
yeah.
start with 5 itself? I will have like 5 5, and I do have like 44. 44 means I'll have like 8 5. So 40, I do have another 4 here, and you'll have 5 8 8. I would be able to divide this by 2. I will be having like,
Yeah, but you can only have 1 5 because
again, I can have,
otherwise
yeah, only 1 5. That is clear. But what about the others?
but you
It
can
can be 2
have
as well. I think the
you
2
can have
can be, the 2
yeah,
can
so
be.
7 and 2 can be what? It can also be 1.
Uh, actually, I'm not, I think the 2 is also not varying, right? See, when you divide this by 2, you are getting only 147. It's odd. So I think you don't have any other possibility for 2. It's not varying. So like 4 3s are 12, and you do have like 9. Yeah, I think this is the only one possibility, Shana. I don't think so. We do have any other possibility than this.
Oh. Okay. Yeah.
Yeah, right?
Yeah,
Yeah.
because it wouldn't be divisible.
Like even and odd we are getting. Yes. Absolutely only this option. Yes. So they are saying that they have this written the 2 power 2 as 2 power r, and 5 power 1 as 5 power t, and 3
So
as
they're just
3
trying
power
to find
t.
all the divisors.
Yes. So they're just writing the ranges of the power as well. So they're saying that uh, the r can vary from 0 to 2. I'll show you how. See, you do have like 2 into 2 here. So do you think uh, I can use 4 also here rather than going for 2 twice? I can use 4. Of course, I'm using the prime factorization here, but if I don't use prime factorization, I can use 4 also rather than going for 2 2s, isn't it? So the 2 can be 0 also. Do you understand, Shana? Do you understand what I'm saying?
Yeah.
I do have two twos here, which means like 2 square. So I'm just denoting the power of the 2 as 2 raised to the power r. What they're saying, the r can be ranges from 0 to 2. It means I can use like 4, or I can use like 1, 2, 3 into 2 is 6. I can use like 1, 2 and 1, 6. Do you understand? I'll just show you. I'll just show you. You'll be able to get it. For example, 2940. So I was using 5, 5, 8, and 8. So I was saying that we can go for 4 rather than using 2. So you will have like 1, 4, 4, 4. You will have like 7. Is it clear, Shana? I can go for
Yeah.
this, which means the value of 2 is 0 now. I mean, the power of
Yeah.
2 is 0 now, right? So the R can be 0. And what if I use 1, 2? Like 2, 9, and I do have 4. And what if I use 6 here? Rather than going for another 2 and 3, what if I go for 6 here? So 6 would be like 3, like 4, 6 are 24, and I do have 5 more. 54 means like 9, 6, right? So I can go for this as well. So the value of R can be 1 also. I can write like 2 raised to the power 0. I can have like 2 power 1. I can have like 2 power 2 also. Do you understand the possibility? Which is why the R ranges from 0 to 2. Is it clear? Is it clear, Shana?
Yeah.
And similarly, for writing the other options, 5. 5, they are denoting the power of 5 as 5 raised to the power t, and it can be only 1, 5 or 0, 5. So what does
Yeah.
it mean? It means rather than dividing this by 5 table, I can directly use 10 table. I can put 294 here. So there is a possibility that the value of 5 can be, the power of the 5 can be 0, which is 1. Is it clear?
Yeah.
Good. So it can ranges from 0 to 1, but it cannot go beyond 1 because you do have only 1, 5 in the factor. I mean, for 5, they were using t, right? All right. And for 3, same methodology. I hope you are able to follow it. And for 7, I was using like 149. I divided with the help of 149. I think we had 49. 49, we divided like 7, 7, 7, and 1. So this can be 2 sevens. It can be 1, 7. It can be 0, 7 also. So which is why you do have like 0 to 2. Is it clear, Shana?
Yeah.
So these are the possibilities. So how I will write it now? Like what is 2 power 0? What is 2 power 1? What is 2? And also write what is like, what is for 3? For 3, it's yes, like 3 power 0, 3 power 1. And what about 5? 5 going to be like 5 power 0, 5 power 1. And for 7, it's going to be like 7 power 0, 7 power 1, and 7 power 2.
Yeah.
1, 2, 4, 1, 3, 5, 7. Is it clear? So these are the devices. And that also I told you, like 2940 can be divided by 10 also. You need to write their product as well. For example, when I divide it by 5, I will be so when I write the divisor, I do have to consider their product as well. I do have to consider the product of 2 and 3, the product of factors. 3 to 6, so I got to include that as well. And 7 into 3 would give me 21. And 5 into 2 would give me 10. Yes. And 10 into 2 would give me 20. Because I can divide 2940 by 20 also, right? 120, and you do have 9, which means like 4, like 7. Is it clear, Shana? I can divide it by 20 also, right? I hope
Yeah.
like follow it. So you have to list down all the prime factor and the product of factors as well. Okay.
Yeah.
Please make sure you have used all the possible combinations.
Yeah.
And once you derive this, you'd be able to create this further. For example, you can multiply 6 and 10. You can multiply 7 and 10, right?
Yeah.
Like you can multiply like 294. Like when you divide 2940 by 10, you will have like 294, which means this is also a positive divisor, isn't it? I hope you're able to follow what I'm trying to say. All right. So when I divide this 2940 by 5, I would be able to get my answer as like, I think it's supposed to be like 588. So that is also there. Is it clear? So I don't have to start with 5 every time. I can start with 2 also. So I would be able to get some different like divisor, like 1470. This is also a divisor, right? So they have just listed down all the possible positive devices here. Just
Yeah.
all right. So now, all right. So now we are just going to check the condition. So look at the condition. So in the condition, we do have y minus 7 plus z minus 7 should be lesser than 203. So we just have to substitute and see whether it suits this condition. So when you check, it's supposed to be lesser than 203. So obviously, you can omit all of them. Is it clear, Shana?
Yeah.
And also, you can omit them by subtracting. For example, you can subtract like 20360. What do you get? You will be getting the answer is 143. So you just see whether you have one. Yeah, you're getting 143, but we don't have 143 here. Since 143 is lesser than 203, you can include 60 in this. So it's just have to be lesser than 203. Or that thing you need to keep in mind.
Yeah.
Okay, so could you please tell me why they have omitted this? Why they have omitted 1 to 15? Can you substitute and check? For example, when you substitute 1, what happens? You will have like minus 60. And again, like maybe if I substitute 2 here, I'll be having like minus 5. So that would result some value in the form of negative, isn't it? Like I'll be having like negative 6 and negative 5 would give me negative 11. I'm not supposed to have negative integer. They have mentioned that it's supposed to be positive only. Do you understand that? Can you follow, Shana?
Yeah.
Okay. So they're just drawing the table for this. So y minus 7 and z minus 7. And you have y, z. For finding y and z, you just have to add 7 more values with this. And here also you just have to add 7 more value. So you'll be having like 20 plus 7 would give me 27. 147 plus 7 would give you like 154. For finding the x, the equation is 217 minus y minus z. So you just have to substitute the value of y and z over here for finding the value of x. Is it clear? Can you follow these?
Yeah.
And do you understand like why do you have 20 and 147 here?
Yeah, because in the factorization, we have those two values, y minus 7 and z minus.
Okay, so why exclusively 147? Why not 105 maybe here?
Because they multiply to get the product.
They multiply to get the product. They multiply.
Because it was the two we were finding a list of multiples, and that if you multiply those two together, you get the answer.
Okay. What is their product is equal to what is y minus 7 into z minus 7? It's 2940, isn't it? This is the condition. So when you
Yeah.
multiply, you just have to check whether it results in 2940 or not. Okay. So
Yeah.
So what is 20 into 147? That would give you like 2940. Do you understand?
Yeah.
I just want to check whether 2140 would mean that I'm not sure. I will be having it from, I mean, like 84. Yeah, yes, Shana. Yeah, I'm getting. So you just have to check their product is results in 2940 or not. All right. So this you know how to get it right. Like y square plus z square minus x square would give you this fact. So do you know why they're doing this?
Yeah.
Why?
So that they can try and find the values of.
Pythagorean condition. You remember?
Yeah. In the question there was one value that they gave us.
Yes. So y square plus z square minus x square is equal to 49. We need this.
So that the only one that solves that is if z is 42 and z is 91 and y is 42.
For this value you are getting.
Yeah.
So now if you substitute the value of s, this is also given in the question. In the question they were saying that, I mean, the remaining three sides have integers length. The sum of the squares of the side length of ABCD is s. So which is why they have written s as x square plus y square plus z square plus 7 square. Is it clear?